Well, hello again to my AB Calculus students. Here's the scoring video for the 2015 free response questions 1 through 3. Now, just a reminder, some of you still seem to be forgetting a little bit how this works. So you should not be watching this until after you have finished the questions 1 through 3 and have them done. And then you should be watching this and scoring your questions. You should not have turned in your questions yet to me. You should score them now according to this video and the guide that the AP establishes, and then record the scores on the work and then submit it to me. So anyway, let's look here at how to score questions 1 through 3. So beginning in question 1, this is one of our classic types of questions. I'm sure they'll have something like this on this year's AP test. It's a rate in, rate out, but probably they would give you the types where the rates are presented in different ways. In this case, both rates are in the form of equations or functions. So we don't have we've had some others where it's been like a table and a function or a graph and a function. This is both functions. So for A, it asks how many cubic feet of rainwater flow into the pipe during the first 8-hour interval. So our function is our rate in function. So we simply integrate our rate in from 0 to 8, and that'll give us the total amount of water that has come in. You get 1 point for knowing to integrate this rate function here, the rate in function, the R. So if you integrate that correct thing, either with have this listed or you actually have the function written out, you get 1 point. If you need to go from 0 to 8 and you evaluate it correctly and get the 76.570, you get the second point. Okay, number 2. Asks if the water is increasing or decreasing at the time of 3 hours. So you first have to understand that what you need to do is compare the rate that it's coming in at time 3 with the rate that is going out at time 3. So if you consider both of those rates at time 3, you get 1 point. That's a pretty soft point. The next point is when you compare them, you must figure out that the rate going out, the D at 3 is bigger than the rate coming in, or if you compare the two of them like this, you'll see your value is negative. So either at some point, though, the key thing is that you can state this. The rate going in is less than the rate going out. R at 3 is less than D at 3. Therefore, the amount of the water in the pipe is decreasing. And that would be your reasoning. Okay, part C is worth 3 points. So part C, it asks when is the water at a minimum. So this is another classic time for the candidates test. Anytime you have a closed interval and they're asking for maxes and mins, you want to use the candidates test where you go and you know you need to check the endpoints and any relative maxes and mins. So what you're going to do here is your endpoints are going to be 0 and 8, so you will have to check them. And you will also have to check any places where you have a relative max or relative min, in this case, relative min. To do that, you check for critical points where derivative is 0. So here's your derivative of the amount of water or the rates. So you're looking for your rate in equals your rate out. In other words, where those two things, the difference is 0. Or you could look for where this equals this. That would be the same thing. So if you consider that, looking for the rates are equal, you get 1 point. And so notice in order to, when you go to find that, you find that that is going to be at the place 3.271. So that means you must check the endpoints and at 3.271. To check at 3.271, and actually we know at the first endpoint you can plug in, we know that it's 30, we're given that. And then we have to integrate the difference of those rates there. When we put in this point, put in that value for T, we get 27.965. When we put in 8 for T, we get 48.544. And we notice here, this is our justification. We have checked every candidate. This is the one where at this time, this is the lowest amount of water. So the minimum amount is this value at that time of 3.272. So that's 3 points. And finally, 2 points for the last one. if you know to integrate and you don't, so your integral, you need to be going from 0 to w or 0 to x or whatever variable you pick there. And you must integrate the difference of the two functions. And if you do that, you get 1 point. If you know that you have to start with your 30 and set it equal to 50 and you do that, you get the second point for your full equation. Okay, score that out of 9 and write that score with that problem, and let's move on to problem 2. Problem 2 is an area volume type problem. So we have these two functions given to us. We're given this picture of the graph. We're also given the equations for the two functions. And for part A, we want to find the sum of the areas, so we have to integrate these things separately here. So what we see is to get the sum of the areas, what we have to figure out is we have to figure out this point where they meet. So notice that that's the first thing that they did here, is they figured out where those functions actually meet. And notice one thing they did to save themselves time is they labeled the x coordinate as A, the y coordinate as B. That way they would have that for the rest of it, and all they had to do was say A and B every time they wanted that. So what they did then to find the area is they know that they would integrate from 0 to that point, that x value there, which is A, which is this 1 point. And they would have to take the difference of the function on top, which is the g of x function, in this case, over region R. This gets the region of S. Notice the f function is on top, minus the g. And so if you get the correct limits, in this case that would be 0 to A to 2, you get 1 point. So if you find that correct value of A there, you get 1 point. The correct integrals, knowing it's g minus f and then f minus g, gets you 2 points. One for this, one for this. And then actually evaluating everything correctly and coming up with a correct answer gets you the 4th point. Okay, part B. Part B now wants the volume, and we've got a known cross section here. In this case, our cross sections are squares. So we know we have to find the difference between, so we know we're just talking S. We have to find the difference between the curves and then square it to get our area. So you can see we're going to integrate from A to 2, and we've got our difference between the two curves. Once we get that distance, we square it to get the square. Plug in 2 points for the integrand, 2 points for this f of x minus g of x, the whole thing squared, 1 point for the correct answer. If you made the mistake of saying f of x minus g of f squared of x minus g squared of x, I believe they would give you 1 point. Okay, for C, you get 1 point for knowing you need to look at the derivative of h. So just the fact you know you have to look at the derivative of h gets you 1 point. And you get a second point if you actually can calculate that correctly. That's the derivative of x minus the derivative of g, and do that correctly and get the negative 3.812. So go ahead, score that out of 9, and then let's move on to question 3. Question 3, classic example. We have rates in the form of a table. I can almost guarantee that at some point you'll have to do a Riemann sum with those to get the total distance, but we'll take a look here. So for part A, it wants us to estimate the value of the derivative of v at 16. So I have to find the average rate of change of v at 16. That's in between these 12 and 20. So you must set up this ratio, change in y over change in x. In this case, it's change in v over change in t, and get 5. So you have to have this fraction visible. You've got to have a fraction of a difference top and bottom in order to get that point. If you just have 5, no point. You got to have the fraction of the differences. Okay, part B. So you need to explain. You get 1 point for explaining that this integral of the absolute value there is going to give you total distance, that she jogs from a time of 0 to a time of 40. So that you have to have that's total distance, and you have to have that it's from the time from 0 to 40 in order to get that point. Then you get a second point for the right Riemann sum. That is this line right here. This line gets you that point, or this line does. If you don't have either one of these lines here or here, and you just jump right from here to here, you just did it in your head or did it in your calculator, you do not get the sum point. Okay? You can still get the approximation point if you have this line or this line, but you don't get the sum point. If you have this line, that gets you both the sum point and the approximation point. You don't even have to simplify to these two lines. So if all you had was this line right there, you would get both points. Okay, moving on. Then for part B, the fact that you know you must use the derivative of the function b there gets you 1 point. That's a soft point, pretty easy to get. Now if you take the derivative correctly, plug in correctly, and get the answer of 15 here, once again you could leave it as 3 times 25 minus 12 times 5, that's okay. That gets you your next point. Finally, your last part D is worth 3 points. 1 point is for the integral. That includes the limits, 0 to 10, and this integrand right here. That gets you 1 point. This antiderivative inside the brackets gets you a 2nd point. Even if you don't have the correct limits, you could still get this if you have what's in the if you have what's inside the brackets correct. And then finally the answer, which is either going to be this right here or simplified down to 350, gets you your final point. Okay, total that one out of 9, total the whole thing out of 27, and then go ahead when you've got it all done and take a picture and post it, and I'll take a look. All right, remember tomorrow we do have a Zoom session at 1:30 if you have questions. All right, we'll see you later.